So in the last lecture we had learned that E and Z nomenclature. So in this E and Z nomenclature, if the two same group, or you can say that if the two same priority group present on same side of your carbon carbon double bond, then that is Z alkene. And if the two same priority group present on opposite side, that is your E alkene. ठीक है. Okay, again in the last lecture we had learned syn and anti nomenclature. Okay, so this syn and anti nomenclature is used for aldoxyme and ketoxyme. So in aldoxyme, if your hydroxy group, OH group, and hydrogen present on same side of your carbon nitrogen double bond. Okay, let's show you the example. ठीक है. So this is your carbon carbon double bond. OH R group. So here in this structure, this hydroxy group and this hydrogen present on same side of your carbon nitrogen double bond. So that's why it's a syn. Okay, and if this hydrogen and this hydroxy group present on opposite side, okay, let's take the example. This is your chlorine and Cl and cis formula. ठीक है, न्यूमन प्रोजेक्शन formula. So let's take the example of ethane. For example, in case of ethane, a point represent the front carbon atom. Okay, for example, in ethane, the point represent the front carbon. Okay, so the structure of ethane is it having two carbon, CH3, hydrogen, front carbon, hydrogen. So this is your carbon number first. Okay, and the line emerging from that, this dot represent the bond that is attached to this carbon. Okay, and now this circle, this is your circle. This circle represent the second carbon. What? This circle represent second carbon, and the line emerging from that circle represent the substituent or the group attached to this second carbon. So this second carbon having 3 hydrogen. So this is your hydrogen number second and hydrogen number third. Okay, so actually this bond is directly attached, this hydrogen is directly attached to this circle. Okay, so this is your Newman projection formula of ethane. This is your what? Newman projection formula of ethane. Okay, so this dot represent the first carbon. Okay, and the line emerging from that dot represent the hydrogen which is attached to this first carbon, and this circle represent second carbon, and the line emerging from that circle represent the bond or the whatever the group attached to this second carbon. So this is your Newman projection formula. This is your what? Newman projection formula for ethane. Newman projection formula for ethane molecule. Newman projection formula for ethane molecule, and this is your this is the front view of your molecule. This is your what? Front view of your molecule. आता imagine करा. What? Here you have to imagine. तुम्हाला imagine करता यायला पाहिजे. तुम्ही what you are standing here and you are looking this molecule from front side. What? You are looking this molecule from front side. So this is your carbon number first, and this is your carbon number second. Okay, you know that this carbon, this carbon is sp3 hybridized carbon, and okay, so the geometry is tetrahedral. So when you look at this carbon from this side, dot represent the first carbon, and the bond angle is 109.25, 109.25. ठीक है, so and this circle represent the second carbon, and this line or the bond emerging from that circle, line or the bond emerging from that circle represent the second carbon, or represent the bond which is attached to second carbon. ठीक है, so this is the Newman projection formula for ethane. ठीक है. So the Newman projection formula is very simple. Okay, so in the circle, Newman projection formula represent the back carbon or a rear carbon. Circle represent the back carbon or a rear carbon, and this, what in general, the front carbon atom is represented by dot. Okay, and the line emerging from that dot represent the bond which is attached to first carbon. Okay, so this is the Newman projection formula for ethane. Okay, so in general, second carbon, we are representing the second carbon by circle, and we are representing the first carbon by dot. Okay, and the line emerging from that dot represent the group or the substituent which is attached to first carbon. Okay, so this is about your Newman projection formula, and this is the Newman projection formula for ethane molecule. Okay, now I will show you Newman projection formula for tartaric acid. Newman projection formula for tartaric acid. ठीक है, so the structure of tartaric acid is COH, COOH group, CH2, CH2. Okay, so this is your carbon number 1, carbon number 2. This carbon number 2 is attached to 2 hydrogen and COH group. Okay, so this is your front carbon. Now we are representing the back carbon. Okay, back carbon is represented by circle. So this circle represent the back carbon or a rear carbon. Okay, so this hydrogen and hydrogen. ठीक है, so this is your front carbon, this is your back carbon. Okay, now for tartaric acid. So this is the Newman projection formula for tartaric acid. This is your front carbon. Okay, front carbon represented by dot, and the line emerging from that dot represent the substituent which is attached to the front carbon, and this circle represent the back carbon or a rear carbon, and to this rear carbon, so this is your carbon number 3. Okay, to this carbon number 3, 2 hydrogen and COH group is attached. So these are the 2 hydrogen and COH group is attached to this back carbon. Okay, so this is the Newman projection formula for tartaric acid. Now the next projection formula is Sohor's projection formula. Okay, so before starting that Sohor's projection formula, let me tell you, so there are 2 conformation are there. Okay, in Newman projection formula there are 2 conformation are there, that is staggered and eclipse conformation. Staggered and eclipse conformation. So let me show you that staggered and eclipse conformation. Okay, so this first one is your staggered conformation. First one is your staggered conformation, because all the substituent, okay, the angle between this carbon number, the substituent present on carbon number 1 and the substituent present on carbon number 2 is 60 degree. Okay, so these two groups are maximum away from each other. Okay, so maximum distance is there, all the bond angle is 60 degree between this and this. So this staggered conformation is a most stable conformation, and this is your eclipse conformation. This is your eclipse conformation. Okay, so in this eclipse conformation, the overlapping between the substituent present on first carbon and the substituent present on second carbon, this angle is 0. Okay, actually this the substituent present on first carbon is overlapping on second carbon. Okay, so due to this overlapping, steric hindrance is there. Due to this overlapping, steric hindrance is there. That's why this eclipse conformation is a less stable conformation. So this is your eclipse conformation, staggered most stable, and eclipse conformation. So for sawhorse projection formula, actually it looks like a horse, that's what is called as sawhorse projection formula. Okay, so in this sawhorse projection formula, for example, in case of ethane, the two carbon atom are drawn as a point, and the bond joining the two carbon is drawn as a line, which is considered to be the plane of paper. Okay, so this is your first carbon, second carbon, and the line which join these two. Okay, let me erase this. Okay, and the line which join these two dots represent the bond between the two carbon atom. The line, this line represent the bond between two carbon. Okay, and the line emerging from that dot represent the substituent which is attached to this carbon. So this is your sawhorse projection formula for ethane. So you know that ethane having two carbon, so this is your carbon number 1 and this is your carbon number 2, and these are the hydrogen. So this is your hydrogen, hydrogen, hydrogen. Okay, so for example, in case of ethane, the two carbon atom are drawn as a point, the two carbon drawn as a point, and the bond joining to the two carbon is drawn as a line, which is considered to be the plane of paper. Okay, so this line is in plane of paper. Okay, so this is your Sawhorse projection formula for ethane. Okay, so actually there is this two hydrogen should away from each other. Okay, they are here, mistake is there, they merge here. Let me redraw this. Okay, so this is your for ethane. Okay, now this is your staggered form. This is your what? Staggered form of ethane. Okay, when you look at this molecule from this side. Okay, so let me show you. Okay, so what, you are looking this molecule from this side, you are looking this molecule from this side. Okay, so this carbon number first is overlapping on carbon number 2. Okay, this hydrogen is overlapping on this hydrogen. Okay, same, this hydrogen is also overlap on this hydrogen. Okay, and this hydrogen also overlap on this hydrogen. So this is your eclipse conformation. This is your what? Eclipse conformation, because the overlapping between the substituent present on first carbon and the substituent present on second carbon takes place. So that's why it's a eclipse conformation. Okay, so and this Horst projection formula, actually it's a side view of your molecule. Actually it's a what? Side view of your molecule. याला तुम्ही असं साइडने बघताय, साइडने बघून ड्रॉ केलं असं वाटतंय, बरोबर. So this Horst projection formula is a side view of your molecule, while Newman projection formula is a front view of your molecule. Okay, so this is Horst projection formula in eclipse form. Horst projection formula in eclipse form. Okay, and its staggered form is this is the staggered form of ethane. Staggered. Okay, now when you look at this molecule from this side, okay, this hydrogen is will come in between these two hydrogen. Okay, and this hydrogen will come in between these two hydrogen. It means that there is a maximum distance. Okay, maximum the these two hydrogen, that is this one and this one, they are maximum away from each other. There is a no steric hindrance between the substituent present on first carbon and the substituent present on second carbon. So this is your staggered conformation and this is your eclipse conformation. ठीक है, एनी डाउट? हॅलो, समजते का रे? आहे समजला? डाऊट आहे का नाही आहे? हा अँगल आहे ना. आता बघ, हा तुझा काय आहे? स्टॅगर्ड इक्लिप्स कन्फर्म आहे ना, इक्लिप्स कन्फर्मेशन. इन इक्लिप्स कन्फर्मेशन सेम, this angle, the substituent present on first carbon and substituent present on second carbon is angle is 0, because this hydrogen is overlapping on this hydrogen. तुम्हाला इथून बघायचं आहे, ठीक आहे? इथून बघितला तर हायड्रोजन या हायड्रोजन वर ओव्हरलॅप होतोय. सेम दिस हायड्रोजन इज ओव्हरलॅपिंग ऑन दिस हायड्रोजन, द अँगल इज 0. while in staggered conformation, when you look at this molecule from this side, okay, so this hydrogen is maximum away from this hydrogen. Okay, so this actually this hydrogen in between of these two hydrogen, it means that the what you can say, that the steric hindrance is, there is no steric hindrance in staggered conformation. Okay, and the angle is 60 degree. Angle is 60 degree. Actually it looks like a horse, that's why it is called as sawhorse. हे तुमचे पाय आहेत. दिस इज युअर फ्रंट लेग ऑफ युअर हॉर्स. दिस इज युअर वॉट, त्या घोड्याचं काय, हा तोंड आहे आणि हे मागची पाय आणि शेपूट. ठीक आहे, ही तुमची शेपूट, हे दोघं पाय, बरोबर. सो दॅट्स वाय इट इज कॉल्ड एज सॉहॉर्स प्रोजेक्शन फॉर्म्युला. एनी डाऊट? stability, same stability as like your what your Newman projection formula. Your staggered conformation is more stable than eclipse conformation. Okay, so this staggered conformation, this one is more stable than eclipse conformation, because in staggered conformation the substituent they are maximum away from each other, so there is a no steric hindrance, there is a no steric hindrance, while in eclipse conformation there is a steric hindrance between the hydrogen present on first carbon and the hydrogen present on second carbon. So there is a slightly steric hindrance is there, and due to that steric hindrance, okay, this your eclipse conformation is a less stable conformation. Eclipse conformation is a less stable conformation. ठीक है, or in other word you can say that this is your higher energy conformation and this is your lower energy conformation. Okay, so this stagger, due to this overlapping or due to this, or you can say that steric hindrance, the energy of the molecule increases, and the molecule which having highest energy, that is low stable, that is less stable, and the molecule which having less energy, that is more stable. Okay, so due to this steric hindrance, eclipse conformation, it's a higher energy molecule, it's a less stable, and your staggered conformation there is no steric hindrance, so it's a low energy molecule and it's a more stable. Okay, so this is about your Sohor's projection formula for ethane molecule. Sohor's projection formula for ethane molecule, same for tartaric acid. Okay, for tartaric acid, just this carboxyl group, carboxyl Fisher's projection formula. Okay, so this okay, so this Fisher projection formula is used for the compound that having more than one chiral carbon atom as a center. Fisher projection formula is drawn as by intersecting horizontal and vertical line. Okay, this is drawn by intersecting horizontal and vertical line. The chiral carbon is considered on the joining point, okay, or the intersection point. Okay, so let me show you that Fisher projection formula of ethane. Hydrogen, hydrogen, hydrogen. So this is the Fisher projection formula for ethane. Okay, and it is drawn by intersecting horizontal and vertical line. Okay, this intersection is your carbon. Okay, this is your carbon number first and carbon number second. So this is your Fisher projection formula, and you can write this Fisher projection formula in 3D. That is, the bond present on this horizontal line represent the bond or the substituent towards you, and the group present on this vertical line represent, it is represented by dashed line. It means that they are away from observer. ठीक है, so So this is your horizontal line, this is your vertical line, and the substituent present on this vertical line, it is represented by solid line. It means that the substituent present on this horizontal line, it is towards the observer, okay, and the substituent present on this vertical line, they are away from observer. Hydrogen, hydrogen, hydrogen. Okay, so this is the Fisher projection formula. Okay, so in this, the horizontal line depict the bond is towards the observer, and the vertical line denotes the bond or the substituent away from the observer. Okay, and this Fisher projection formula is drawn when the compound having more than 2 chiral carbon or the 2 chiral center. Okay, and this Fisher projection formula is drawn as by intersecting horizontal and vertical line. Okay, so this is your Fisher projection formula for ethane. This is your horizontal line, this is your vertical line, and you can write in a 3D. Okay, so whatever the groups or the substituent present on this horizontal line, it is represented by a solid line. It means that this hydrogen are towards the observer, and the substituent present on this vertical line represent the group or the substituent present away from the observer, present away from the observer. Okay, so this is the simple Fisher projection formula for ethane. Okay, and now for I will draw त्याची स्टेबिलिटी काय नाही. स्टेबिलिटी बघ, here stability is all the groups are away from each other, so it says stable, there is a no stability factor. ठीक आहे, दोन्ही. आता काय, हे आपले इमॅजिनेशन आहे. आपण जेव्हा याचं इंटरकन्व्हर्जन तुम्हाला शिकवेल ना मी, ते मला कळेल किंवा आपण हा फक्त एकाच फॉर्ममध्ये लिहितो. ठीक आहे, आणि जो तुमचा न्यूमन आणि सॉहर्स प्रोजेक्शन फॉर्म्युला, त्याच्यामध्ये स्टॅबिलिटी फॅक्टर आहे, त्याच्यामध्ये तुमचा स्टॅगर्ड पण आहे, एक्लिप्स पण आहे, बरोबर. याच्यात तसं नाही आहे. आणि वेन वी सी द इट्स इंटरकन्व्हर्जन, दॅट टाइम यू विल अंडरस्टँड व्हॉट इज फिशर प्रोजेक्शन फॉर्म्युला इन डिटेल. ठीक आहे, स्टॅबिलिटी फॅक्टर वगैरे एवढं काय मॅटर करत नाही याच्यात. ठीक आहे, सो okay, so this is your Fisher projection formula. You can simply write down the question may be asked. Okay, question may be asked like that. Write down the Newman projection formula of 2,3 dichlorobutane in its staggered form and eclipse form. Or the question may be asked, write down the what you can say that Sohor's projection formula for ethane. Okay, if the question is like that, then that time you have to write both your staggered form and eclipse form as well. ठीक है. Any question? Yes. हो, सगळ्यात जास्त स्टॅगर्ड फॉर्म मोस्ट स्टेबल असणार.